I'm going to talk about ontology supported frame classification. But first, let me make some introduction. When a few months ago, maybe it was at the end of the last year, Professor Koeva contacted me. Yeah, okay, sorry. She asked me to help her with finding some people that could make a software development for a project. And I agreed to help her find some people, but 4 months later, I didn't find any volunteers. So she said, okay, you will do that. And here, okay, so here I am. And I will try to present you the technical part of our work without being so technical. And that's why the focus of this talk will be a software system called BlueFrame, which is a web-based system aimed for creation, editing, validating, and working anyway, managing so-called conceptual frames. Yeah, so here I will not talk about what are the conceptual frames actually, because it is not my domain, and I will try to not sound so stupid. But the concept here is that this system actually works with two major artifacts. One of them is the conceptual frames, which are abstract structures that defines the compatibility, semantic and syntactic, between verb predicates and non-arguments. The most important thing, actually, for myself, is that the frame structure is a pure hierarchical structure. So we can have a lot of attributes that describes a frame, and those attributes can be organized in a hierarchy or in a tree structure. And the root of the tree is the frame. So that's my point of view about what is a frame, and the hierarchy here is the most important thing. The other artifact, actually, this is the lemma, the verb, which is also which also can be presented as a hierarchical structure with characteristics that are again in a tree structure. So we have two artifacts which are completely different. They serve for completely different purposes, but they have the common structure, the hierarchy. Actually, yeah, the abstract structure is common. And now we have some challenges here to make a system, software system that can work with those two artifacts without knowing in advance what and how many attributes and characteristics we will have in our system. It means that the goal was to create a system that will be able to define dynamically the structure of those artifacts, and this structure should be able to be we should be able to modify it, to change it at any time in the future. And so this doesn't mean that Professor Koeva didn't have idea what are the hierarchy of those things, but we wanted to create it as flexible as possible. So the the system has actually 3 models. One of them is the metadata model, which we are using to define the structure of the data that we work with. The second model is the data model that is used to create and to manage the artifacts, the frames and the lemmas. And the third model, which is missed here, but I will show it later, is the model that is used by the users. I mean, the public part of the system. So about the metadata part of the system, I'm not going to speak here about the tables. They're shown here only to have a view that the tables in the database actually are not much. So we have here about 3 or 4 tables that are used to define the structure of the artifacts that we will work with. And then we have an editor, which looks something like this. And with this editor, actually, we can, let me see how this works. Oh, yeah. Okay, with this editor, we can define the attributes. Here we have actually the structure. We are defining the structure for the lemmas. So we can define the characteristics, their type, and if there are some predefined values for some of the characteristics, we can also define them. So this is only serve only as a template for a structure that can be used to define a word or a lemma. We have the same thing for frames, but because the hierarchy here is much longer, I tried to create a, what's this? I tried to create a short clip. So we can see actually the full hierarchy. Yeah. Did I stop it? So you see that the hierarchy is big for my understanding, and it can be managed, can be changed, and it can be developed in the future also without losing the current data that are stored there. So I did something, I'm not sure what. Yeah, okay. And the second part is the part for the actual data. So we have the structures, we have the abstract structures that can be used as templates to define the both artifacts. And now in just a few tables, actually 3 here, we can define everything about the lemmas, about the frames that we have in our system. You can imagine that if we need to create a classic application where each attribute is stored in a separate column in the database, and if we need to present this deep hierarchy as separate tables, we will have much more tables here with much more relations. And it will be much harder if we want in the future to extend the structure. If you want to add an attribute, to remove it, to change a type or something like this, we will need to change the database model. We will need to change the implementation of the system. We will need to change the user interface. But currently it is not like this. Everything is flexible and dynamic. So here we have a so-called object editor, which uses the templates created with the metadata. And it allows the data to be filled, to be modified, and things like this for each of the artifacts. This one is about frames, I think. Yeah, and this one is about words. They're similar, but they work on different structures. And this is the full data model, which is quite simple. If we have in mind that the things that I already said about flexibility in our model. So I'm going to make quick presentation of the live system, something that I should not do because probably something will break. But yeah, as I am a male and I leave all the things for the last time. So I was going to create a video clip about this, but yeah, it didn't happen. I have no idea why this is not working. Oh. Thank you. So first, the protected part. Do we know the passwords here? Yeah, at least the security is working. Может быть. Okay, it works. So okay, so here is the metadata part where we can define the structure, the template for one of the artifacts that we are working with. And do you see something? Yeah. Okay. So this is very easy to work with this structure. We can add new attribute. I will not do that. Or we can actually modify some existing. I will not do that either, but I will show you. There are some types, predefined types of attributes that can contain different kinds of information. The simple one is text, number, but we have some more complex things like relations to other to lemmas and to other frames. And we can also define if the attribute is required. Yeah, okay. If the we have some limits in the occurrences, in the number of occurrences that this attribute can happen, and things like this. So the hierarchy is somewhere here. Yeah, we can create unlimited levels of depth of the hierarchy. And this template actually then is used here in the editor. And we can, yeah, okay, we can use this editor to fill the data based on the template that we already created in the metadata part. Yeah, you can see that, okay, this is not intended to be used in such small resolution. But yeah, you can see that the hierarchy is here, and we can fill it, fill the data according to the types. And I'm going to log out and just show quickly the public part. The public part is very simple. We see here only the top of the iceberg. Yeah. Anonymous user can search for words, by example, and can see part of the who data that we have in the database with its hierarchy and so on. So that's from my side. Thank you.